Hi again! In this video, we'll proceed with our Godot 4 tutorial and create a level system for our game. I think it wouldn't be wise to expect players to play through our game without any interruptions, so it's essential to implement milestones, checkpoints, and similar features. To achieve this, we will introduce levels as standalone units. This approach will allow players to experience the game incrementally, providing natural breaks in the gameplay. The most straightforward way to create a level in our game would be just to make a new scene and add nodes of all enemies to the scene tree. But of course, we don't want to use this system. The levels would be too static, always the same. The scene tree could become easily overcrowded, and the replayability would be reduced because everybody would know exactly what to expect at the start of the game. So instead, we'll create dynamic waves of enemies with unique randomized characteristics for each gameplay. And to do that, we will employ a custom script for every level. This approach ensures that the enemies remain somewhat original and unpredictable. Now, let's examine the fundamental components of this system. So, in the beginning, we have a singular enemy as a foundational building block. In fact, we already did that before with our asteroids, but asteroids were hard-coded in the game manager script. Now we will make it more flexible in a level script. And we will again utilize the dictionary structure. If you are familiar with the JSON format, you'll find that the dictionary structure is quite similar to that in terms of functionality and syntax. Now, allow me to create a sample event that showcases the utilization of this structure. I will subsequently demonstrate its integration within the game at a later stage. So we'll start with this part, which is basically a simple event. What does it mean? Once the enemy is spawned, its own lifecycle clock will start ticking. And when its internal time reaches 2 seconds, which is this part, the assigned event fire will be performed. This event has 2 additional parameters. Shot, which is set to UFO bullet scene. The enemy shots a bullet defined by this scene. And weapon. We defined that the bullet would be fired by the weapon called main. Besides, it's essential to configure the enemies themselves. These objects require specifications for their display, including attributes such as position and scale. Additionally, they should possess basic behaviors like movement, involving translations and rotations. To encapsulate these characteristics, we will define the appropriate structure, which I prepared here. Does it look familiar? Yeah. We previously employed a fixed spawn structure to incorporate asteroids in the game scene during one of the previous videos. So, while the underlying concept remained unchanged, we intend to enhance it by converting it into a more adaptable framework. And the last thing, the enemies are organized in waves. For instance, we can define the following wave. Basically, the wave of asteroids is initiated 1 second after the level starts, and its life cycle is measured from that point onward. The function getAsteroidWave is programmed to control the entire wave process. And of course, it's crucial to load a specific level to initiate gameplay. As we have established in this part, our level is represented by a script that encompasses enemy definitions, waves, timelines, and events. We will invoke this script from the main scene. But before we start, let's create a script called tutorial and we'll save it to a new folder, levels. We'll add a simple wave of asteroids to it. So let's switch back to the Godot editor and we will create a new top level called top folder called levels. Let's find it. Here it is. And we'll right click and create a new script called tutorial GD. Okay, let's open it in the editor and implement something here. So first we need to include the asteroid scene. So let's find it. I think it is here. Yeah, drag and control and add, of course, var. Nope. Sorry. Here, start of the line. Asteroid scene preload. You may wonder why I didn't use the annotation already this time. The reason is that we'll be adding these scenes dynamically, and it is likely that when we need to do some initial part of the particular asteroid instance, it wouldn't be fully already in the scene, so just already would interfere with this. Let's define some basic parameters of the level. First, we need a timeline, so we can track the events based on the elapsed time, which we define as well. Elapsed time is 0 at the start, and we also want to define what we call previous second. The reason for this variable is that we will be doing some checks, but we don't want to do it on every frame. That would just slow down the game, so it's perfectly okay to do it just every second, once a second. Now, we don't need these functions because we will use the process function from the main script, and let's create the function in it as usual. Node, and yeah, that could be fine for now. And we will add timeline, and let's append the first wave that should be, as I mentioned, asteroids. So timestamp we will set to 1 second after the game is started, and wave would be asteroids. Get asteroid wave. Okay, this function doesn't exist yet. Let's create a temporary placeholder so we get rid of this error pass. All right, and now we need to add the function process that would be called on every frame from the main script. Node delta. So first we need to update the elapsed time based on the delta value, and now if elapsed time minus previous second is greater than 1, let's increment the previous second and do what we want to do once a second. Every second we'll check all events in the timeline and find the events that are due to be performed. If event timestamp is less or equal elapsed time and not event has processed. This flag will be added to every event that has been processed, so we don't accidentally process it again. Let's call the function process wave, which is not there yet. Node event wave, and let's mark it. Event processed is true. Very well. Now we need to add the function process wave. I just got rid of these tabs as I don't like them. Func process wave, node wave, and for every item in this wave we need to instantiate the particular enemy. This item enemy instantiate and call the init function as we always do, node item spawn item timeline, and finally let's add it to the root node. Node add child enemy. Very well. And we still have, okay, something is not correct here. Identifier enemy, of course. This should be better. And now the get asteroid wave. Let's do the basic implementation. So first we want to define the array that we will fill in this method and return at the end. Now we need to assign something to it. So let's create, for example, 11 asteroids in this wave, and we will append to the wave array the following structure. Enemy would be the asteroid scene. We already imported here in the top. Now spawn parameters, we already know them from our asteroid wave, which is hard-coded, so let's do it in a very similar way. First, hit points we set to 20 as before. Coordinations, exactly where the asteroid would spawn. Now we want some randomness in here, so we will do it just like before with vector 3, and we'll use a method from utils to make it easier for us. Get random x in viewport. This is another utility function which I didn't implement yet, but I definitely intend to, so let me just finish this part. Game manager, boundary, top minus I multiplied by 2. This is a z coordinate, and it will ensure that the asteroids would just enter the scene one by one as a wave, but not just a solid line of asteroids. It will look definitely better. Now scale, we want to randomize that a little bit. Utils get random vector 3 in range 1 and 4. Now direction, that would be vector 3. Again, we want the asteroids to go from top to bottom, so x would be always 0, y would be always 0, and z, the actual speed in the z direction, let's make it a bit random, 5 and 15. Okay, that should be all, I guess, for the spawn structure. And the last thing we need to define here is the timeline. And the timeline is empty because we don't expect any behavior with asteroids. They just drift through the space and want to collide with us. Okay, and now the function I mentioned here. Let's go to the utils class. By the way, I just made a control click to get quickly to this class. It is a nice trick which also works in other IDEs for other languages. Func, and viewport, and let's add an optional padding here because we don't want the asteroid to be just too close to the edge. As we know, we placed our invisible walls there so the player's ship wouldn't be able to hit it. And return randf range. That would be from game manager boundary left increased by the padding, and game manager boundary right decreased by the padding. Okay, that's it. Simple function. You may have noticed that I added a new parameter in the tutorial script to the enemy init function. We added timeline, which is not present in the enemy script yet. So let's just fix it to make sure that the game won't crash when the function is called. Okay, we don't need to do anything with that for now. Now, let's proceed with the level loader implementation. We will create a new autoload script here. Right-click, create new script. We'll call it level manager. Level manager. And just like before, we have to add it to the autoload section. Click find level manager, add. Okay. Let's open the script and we will add a function load level. Let's get rid of this part. First, we define a variable current level so we can remember which level is currently active. And now func load level, which would be the level name corresponding to the script name. Current level is load, and now res levels plus level plus GD. As you can see, we can concatenate these parts without any conversion because all these parts are strings. There is nothing like str because we don't use numbers here. And return current level. Okay, why did we use load instead of preload? We use everywhere else. The reason is that a string is not static and preload requires to be a static string that is known at the time of the game start. So this is why we load it dynamically. However, loading of the script would be so fast that we won't just notice any difference anywhere. We will call this function from the process in main GD here, and process. So first we need to make a reference to current level here as well. And we want to know that the level was fully loaded because later we'll be doing that asynchronously. False. And in process, there it is. If level loaded, let's increase the indentation. There is a simple trick. Let's select all these lines and press tab. There it goes. And of course we need to do something when the level is not loaded yet. This is exactly where we'll do the level loading. Level manager. load level, and the name of our level is tutorial. Later, we'll create a sequence of levels and fill this parameter dynamically, but right now we have only one level, so we can do it in this simple way. Current level, init, and we'll pass the reference to the main script, and level loaded can be true. Okay. Now that we have a level definition script in place, there is no longer a requirement for the function spawn asteroids in Game Manager. So let's get rid of it. Let's find the function spawn asteroids, where it is. Yeah, here. Okay. Let's select it all and delete. And of course we need to delete the corresponding call from the main script, which would be here. Okay, there we go. By the way, it's worth noting that the current system of loading levels may not be the most optimal, as it blocks the main thread until the level is completely loaded and initted. However, we will address this concern at a later stage when we delve into improving the game's performance. By implementing suitable optimization, we can mitigate any potential drawbacks and ensure a smoother and more efficient level loading process. I suppose we don't want to fight only against asteroids that are pretty passive. Let's proceed with modeling and incorporating several ships that have the ability to launch projectiles. This time I skipped the part of modeling a new ship in Blender. Let's just suppose that we already have it, and we will import it into the folder models. Here it is. I'll just drag it here. It's importing. Okay, done. And we will use the usual trick to create a new scene out of it. Right click. Okay, it doesn't seem to work for some reason. I think it happens occasionally, and we need to restart Godot to make sure that the script is correctly recognized. Let's see if it helps. Models, here, right click. Now we can do that. New inherited scene, and it should be here. Yeah, I think it was a fire texture or fire photograph I created somewhere and used it as a texture. It looks pretty interesting. So now we will change the root node to area 3D, as we always do. Area 3D, and assign the existing script enemy GD. Let's find it. It should be here in scenes, enemy. Okay, load. We will also need to add this ship to the correct groups, and it would be modules, because it consists of modules, and it will just turn into floating debris after we destroy it. And of course it should be the group enemy, and last group we will use is metal. So each time the ship is hit, our sound manager would play this metal sound we imported. Let's verify that the signal area entered is linked to the right method. Double click and connect, and it should connect to an area entered which already exists in the script enemy GD. The next thing is that we need to set the layer and mask in the system of collisions. So let's click it again. Collision, we use layer 2 for enemies and mask 3 to interact with the bullets fired by the player's ship. Okay, and what else? I think we don't have a collision shape. So let's do it. Right click the root node, create collision shape 3D, and I think we can use two shapes here, one for the body and second for the wings. So we will edit a box shape and click it and change the dimensions to fully cover cover the ship. Let's try 5. Is it showing something? Perhaps 20. Yeah, there it is. Too long. Let's change it to 10. Maybe still too long. 8. Okay, that should be fine. And increase the width a little. 2. Yeah, definitely. Perfect. And the next collision shape, let's just create right click and add child node collision shape. And again, we will assign a box shape. Click it. This time we want to set X to, what was it, 6? I know, more. 10, even more. 15, too much. 12, very good. And make it a bit wider. 2, fine. In fact, we can have as many collision shapes as we want. All of them would send the event area entered to the linked root node, which is this one, and the script, of course. Last thing we need to do with the model is to add the weapons. It seems that just to keep it simple, we'll use only one weapon here. So let's create a new child node of node 3D and name it weapons. Right click, add child node, another node 3D, which would be called main. And right click, child node, node 3D, direction. Okay, let's take a top view and move the main node to the nozzle here, and direction should be definitely in this direction. Fine. We should be finished with the UFO ship model. And before we do the required modification in the script, let's save this scene to the scenes and call it UFO ship at TSCN. Save. Perfect. Now we'll open the script, enemy GD, and we need to add the weapons which are not there yet. Let's add var weapons is empty array, and now in the init function we will detect the node containing the weapons in get children of the root node, and if node name is weapons, let's take its own children to create an array of detected weapons. Cool. Now we need to implement the shooting events in lifecycle. Let's open that, and first we need a new signal called weapon fired. Enemy event. So we want to inform the main script which enemy fired and what kind of bullet, projectile, missile has been sent to the player's direction. Now we need to add a timeline here as well, because we'll be calculating these events, and the same trick where previous second is 0. Okay, let's improve the root, the init function. Event spawn, we need to add the timeline here and assign it to the timeline. And before we proceed, since we changed the method signature, let's get back to the enemy script and call it here properly at the timeline, so we can finally use that. Good. And of course, new signal must be connected. Let's copy this line and copy the signal name, weapon fired, and method should be probably on weapon fired. Great. Okay, let's proceed with the function process. So we need to check the timeline like we did in the tutorial script. If elapsed time minus previous second is greater than 1.0, let's increase the previous second and process the events for event in timeline. If event timestamp is less than or equal to elapsed time and not event has processed. Again, we want to process each event only once. Event enemy event and event processed is true. Yes, we have this new method, process event. Let's implement it. Func process event enemy event colon, and we have only one event, which is to fire a projectile. So let's implement only this one. If event has fire, we should make sure that the enemy is still visible on the screen, because it doesn't make sense to fire something when it, for example, passed through the bottom boundary. So if event fire has weapon, which means the weapon parameter is defined, otherwise there is nothing to shoot from, and game manager is in boundary enemy, will send the signal weapon fired, emit enemy event. Okay, now we need to connect the signal in the main script. Let's open it, and it would be here as a new method, func on weapon fired enemy event game manager fire enemy weapon, passing the root node again, enemy and event. Okay, of course this method is not there yet. Let's add it to game manager. Func fire enemy weapon root node enemy event for weapon in enemy weapons. If weapon name is event fire weapon. What's that? It means that let's get back to the tutorial script. Here it is, and we defined this event. What did we? No, we didn't yet. It's in this text file. We define this event as shooting the weapon main, which is why we make this check here, because if the ship has more weapons, we want to fire from the correct one. So where were we? Here, enemy fired weapon. And again, if is in boundary weapon false, I think there is just no toleration of some margin, which is what the false means. Var bullet is event fire shot instantiate. Yeah, we define the bullet scene in the level definition as well. This is this one, UFO bullet scene, and we need to init that. Init weapon enemy rotation. Why? Because it is likely that some enemies would just pursue us and won't always shoot from top to bottom. So we need the correct rotation of the enemy object and apply it to the bullet accordingly. And last thing, add it to the node tree. Add child bullet. Okay. The scene is prepared for trying out, but before we proceed, we need to create the enemy bullet scene. And in fact, we have two options available to accomplish this. One would be to reuse the existing bullet scene we use for our for the player's ship. However, if we opt for this approach, we need to be aware that the bullet object employs layers and masks to collide solely with enemies. To make it interact exclusively with the player's ship, we would need to make some changes programmatically, and in fact, I don't like this way too much. So let's do it the other way, which is we will simply duplicate the scene, bullet tscn, let's Ctrl D, and we will call it UFO bullet, duplicate. Then we can modify the duplicate scene accordingly, and we will set all parameters right here. First, we need to duplicate the script which is associated with the bullet scene as well. Let's find it here, press Ctrl D and name it UFO bullet. Okay. Now it's necessary to detach the current script, which is bullet GD, from the UFO bullet scene, and we'll do it by pressing this icon and then press it again, and we will assign UFO bullet. Now it is correct. Okay, and of course we will delete trail because we don't want to use trail for this kind of bullets. Otherwise the screen would be just full of lines and it wouldn't look nice. So let's delete this node. Okay, and we need to get rid of all mentions of trails in the script. This one and this one. Fine, I think it could work. And of course, yeah, layers. So let's open the collision system, and we need to change collision layer to 4, and the mask, I think it can stay as it is. All right, and one last thing, let's go to groups, remove the group bullet. Let's add a new group, UFO bullet, add. I think the enemy bullet shouldn't be as fast as the one which is fired by a player's ship, so otherwise the game would be basically unplayable. Let's decrease the default speed to 20. Okay, I think everything else can stay here as it is. Now we will proceed with enhancing the enemy timeline in the script tutorial GD. Let's open it. And first we need to add new scenes here. We need the UFO ship and the UFO bullet. So where it is here, drag and control drag, var UFO ship scene is this, and var UFO bullet scene is this one. Control, preload. Great. Okay, and we will add a new timeline here. The second timeline, let's suppose it will be activated 1 second after the first one, and we will call the method get UFO ship wave. And of course we need to implement this method, so let's scroll down and create it here. UFO ship wave, and again we need to, I think we can copy the body and make just a few adjustments. So wave, right, okay, 11 ships, why not? And the enemy is now UFO ships, UFO ship scene. Hit points 20, we can leave it as it is. We'll just make something different here. So instead of flying into the scene one by one, we will make them fly in a formation. Minus 50 plus I multiplied by 10. 0 is correct. And game boundary top, let's make it plus I. Okay. Scale. Unlike asteroids, the ships should be probably all the same, at least at this phase. So let's just make them a little smaller. I think that the original model is too big, so they would just overlap. So let's make them half their size in all dimensions. Okay. And it seems that I forgot to add rotation to asteroids. Let me fix it. I'll just copy this line from the text file I'll be showing before. And now we want to change the direction of the UFO ships. In this case, we won't do some randomness. We'll make them all run in the same speed. Let's just set it to 2, so they are not too fast. And finally, let's make them rotate a little bit. Rotation. And they will rotate along the y-axis. Is that y-axis? No, it would be z-axis. So, vector 3. I keep pressing the wrong arrow, sorry. Vector 3 or not. Yeah. 0, 0, and how much? 0.5, of course, why not? Okay, and timeline. Because the ships will be shooting projectiles, we need a timeline to set it up. So let's create function get UFO ship timeline. Okay, and implement this method here. Func. And we will return a simple array for now. And this array would just contain one JSON structure. Timestamp is 5, which means the shot would be fired 5 seconds after the particular ship is added to the scene. And the event is fire and has these parameters. First shot would be the UFO bullet scene, and weapon is main. All right. Is there something incorrect with the structure? Yeah. No, one more curly bracket here. Okay. I'm missing a comma here, of course. Okay, so I found a few bugs in the code. First of them was that we'll be missing the angle here as a new parameter of the UFO bullet init function. So I added this part. and I added it here, which means because sometimes some weapons can be just pointing to sides or in different angles than the enemy object is oriented, so they would shoot in a wrong way. This is the first thing. And the second one, we made a mistake with indentation here. Of course, it doesn't make sense to do this else at this part. It should be this and this, because if it's not enemy impact, if we've been hit by a bullet, then the bullet object should be destroyed. If we just keep it there, the bullet would hit us, it would be reflected in the hull integrity on shield power, but it would continue going down with no changes. Now we can test the game. So first wave, asteroids, and second wave, we have ships, and let them shoot. Yeah, there it is, and we've been hit. And let's try to do something with the shield power to test the integrity. Yeah, it's going down, and we are finished. Okay, I think the first level, we can call it, is done. In the next video, we will add some power-ups to improve the abilities of the player's ship, and also we will launch homing missiles to pursue our hero.